Um, okay, the recording has been started. August, please feel free to take it away.
Cool. Thanks, Mike. So we got a cool one today, and I want to just kind of quickly intro it and then hand it straight over. We've got two OCM community members, Takeuchi-san and Sugimoto-san, and they're going to speak about their dynamic scoring framework. The framework's cool. It's about always challenging and super familiar problem we face with balancing like resource efficiency, data currency, making it all work. So I'm super excited to see this and looking forward to hearing from the team. As Mike said, this will be recorded and the notes are there. So I'll hand over to Takuchi-san and Sugimoto-san. You guys can share screens or whatever. But yeah, let's just hear it. This sounds great. So thank you for joining us, and over to you.
Thank you. Can you hear me?
Yes, we can.
Yeah, sounds good.
Okay, thank you. Okay, thank you. Okay, let me start sharing my screen. Okay, hope you can see.
Yes, we can.
Yeah. Just a moment. And I need to let me. Okay. Okay. First of all, very nice to meet you. And yeah, we are newbie. And yeah, thank you for having this opportunity. So beginning with the self intro. So today we would like to give you introduction to something called dynamic scoring, which is a new feature for OCM. Okay, so the agenda looks like this. So let us introduce ourselves to you, and we'll give you a background and a context why we need something like this, and then we explain the dynamic scoring. Okay, so. So first of all, yeah, my name is Shinta Sugimoto, and I'm a research engineer from SoftBank R&D. And today I'm together with my colleagues Takeuchi-san and Mori-san. Yeah, so Takeuchi-san is the main developer of the AI-run orchestrator. And Mori-san is the leader of the AI-run orchestrator development team. Okay, so yeah, that's us. Yeah, and so first, let me give you a little bit of context and the background. Okay, so yeah, we are working on something called AI Run. AI Run is a concept to run both AI and run workloads on a common IT infrastructure. So we expect that there will be growing demands for AI computation in the upcoming years. To respond to this, we aim to develop an IT infrastructure where we can flexibly manage resources such as CPUs, memory, and GPUs. Yeah. The IT infrastructure is actually a group of Kubernetes clusters. Yeah. So, yeah. So we expect that there are dozens of Kubernetes clusters that are deployed in a distributed manner in a regional data centers. Yeah. And the OCM plays an important role here for multi-cluster management. Yeah, as you can imagine, we need to deal with many Kubernetes clusters. Yeah. And we are actually using a Red Hat Advanced Cluster Management, ACM, for that. Yeah. And the ultimate goal of the AI Run orchestrator, is to coordinate efficient resource utilization of the AI Run IT infrastructure. So in order to do so, we need to take into account various requirements, such as availability of computing resources, such as CPU, memory, and GPU in the target cluster, target environment. And also, energy consumption is a very important issue to consider because execution of AI workloads are known to be energy hungry. Yeah. Okay, so we need to deal with these multiple factors. Yeah. So we reached to a conclusion that we need something, a framework for evaluation, kind of an evaluation framework, which has the following capabilities. Yeah. So, sorry, before going to that, this is another diagram which explains how the system looked like from Kubernetes, mainly from a Kubernetes viewpoint. So please note that we have a centralized central data center, a Kubernetes cluster, which is named management cluster, where we run the orchestrator app here. And as I mentioned, we need a multiple cluster manager, OCM, actually Red Hat ACM, yeah. And also we are using GitOps and the Git in order to manage the Kubernetes clusters in a ISE manner. And at the bottom, there are many workload clusters. Yeah. Okay. So the overall architecture looks like this. Okay. So let us start explanation of the dynamic scoring mechanism. Yeah. So in order to address the requirement that I explained, so we need an evaluation framework which has the following capabilities. So one is that, we need something that can work in a multi-cluster environment with scalability. To be more specific, it can apply the mechanism uniformly to the multiple clusters. Yeah. Another aspect is that the performance must not be degraded, even when the number of clusters increases. Yeah. Secondly, we need to the framework should be able to handle multiple factors, as I explained. Another thing is that the framework should be capable of handling metrics from each cluster in a real-time manner in time series. Yeah. Okay, so so here is the system overview of the dynamic scoring mechanism. Yeah, let me explain. So there are major components. Yeah, the ones colored in red, light red. So most importantly, there is a controller running in a hub cluster. Okay, so this is the centralized control plane of the dynamic scoring mechanism. And on the right side, we see two managed clusters here as an example. Yeah. And for each managed cluster, on each managed cluster, we have an agent called the dynamic scoring agent, which gets deployed in each managed cluster. And the DSA, let me call it DSA, is deployed through the add-on framework of OCM. Okay. And the DSA plays the following roles. Yeah. First, identifying the scoring APIs that it needs to deal with. Yeah, there is another major component called the scoring API, which you can find in the bottom of this diagram. Yeah, the blue one. And so they are the ones which actually executes the computation for scoring. Okay, so DSA identifies which scoring API it needs to deal with. Okay, and secondly, DSA collects metrics required by the scoring APIs from Prometheus. Yeah. Here you see that in each cluster, the assumption is that the Prometheus is running in each managed cluster and providing metrics. Yeah. So, and then DSA, sadly, communicate with each scoring API respectively. So please note that the scoring API, there may be one or more scoring API involved. So in this example, we introduced two scoring APIs. One is labeled internal here, and the other is labeled external here. So in this example, there are two, but you can define whatever. If you like, if you need to involve three scoring API, that's also possible. Yeah. So yeah, and then the scoring API, as I mentioned, is a workload dedicated to perform scoring. In other words, it performs evaluation, yeah, as per its own definition. And the scoring API workload may work internally or externally. Internally means that it runs in one of the managed clusters. So in this case, cluster number 1, yeah. And externally means that it runs outside of the set of managed clusters, yeah. Okay, and so that DSA in each managed cluster needs to talk with these scoring APIs somehow. Yeah. So when it comes to the internal scoring API, we need this pod to be reachable from these managed clusters. So we need something like Scupper. We are actually using Scupper to enable the reachability among the multiple clusters. But some other mechanism can also be used. Yeah. So that's the overview, and then I think I need to hurry a bit. Okay, so let me give you explanation how the procedural steps in what order the system works. So beginning from at the beginning, let's assume that this dynamic scoring function or feature is installed. Then the software, the red components will be installed. Okay, and secondly, we initialize the scoring API, yeah, workloads here, either internally or externally, or both, yeah. And thirdly, we create and apply configuration for each scoring API. So in this example, let's assume that there are two kinds of scoring API here. One is internal, one is external. So here on the left bottom side, you see custom. This is a custom resource, newly defined, named the dynamic scorer. So each of this custom resource corresponds to a given scoring API. Okay, so that's why we have two CR here. So we need to create this custom resource and apply it in the hub cluster. Okay. And then this controller will perform a health check towards the respective scoring API. Okay. And next, we need to set another config, which is named dynamic scoring config. Yeah, here. This is needed, that single custom resource is needed for entire system. And apply this in the hub cluster. Then accordingly, the controller will generate manifest work custom resources. Yeah. So, which is depicted here. Yeah. And please note that this manifest works is prepared per each managed cluster. So in this example, there are two managed cluster, 1 and 2. So that's why we have 2 here. And once this manifest works is created, it will disseminate config maps to the respective managed clusters. Yeah, so that's what this arrow means here. Okay, and then then the DSA, now we are ready to this DSA, the dynamic scoring agent, is ready to be run. Okay, and so maybe it's a bit tricky to understand, but DSA, what DSA does is that as per the configuration provided by the controller through manifest works, it identifies which scoring API it needs to deal with, so starts communicating. Yeah, and the scoring API exposes some endpoints, and one of the endpoint is /config from which the dynamic scoring agent can identify what metrics are needed and how it should communicate towards the scoring API. Yeah, and then required metrics will be collected from the Prometheus here, and and so on. Yeah, and most importantly, so the purpose of this purpose of this DSA is that it needs to get the score from the scoring API. Okay, so that scored the resulted score, which is provided by scoring API. The DSA exposes the score by, it serves as a metrics endpoint by itself. So DSA exposes metrics endpoints, and this Prometheus, on this Prometheus, there is a configuration of service monitoring. And service monitor, according to the service monitoring, the Prometheus is able to collect metrics from the DSA. And then finally, the collected metrics will be sent to the centralized the Prometheus running in the hub cluster. So that's how the system works. Yeah, okay. And then we have a short demo video, but let me quickly show it. But if you have any questions so far, please, raise any questions if you have. May I continue the demo video?
Yeah, please. I think a demo will help us understand it a bit more. Thank you.
Okay. Okay. 竹内さん、ちょっと旧バージョンになっちゃうけど。大丈夫だよね。Okay, let me, okay, hope, yeah, so the length is approximately 6 minutes. Yeah, so let me start. Yeah, there are some, there is no audio, so I may pause and so in this example, we have a hub cluster and the two managed clusters, same as okay. So please note that we are running this system with kind. So each cluster is running on top of a container, actually. So, you know, just a note. Yeah. Okay, so there is this is a Scholar, yeah, which is named the LLM Forecast Scholar. Yeah. So it's a scoring API. Yeah. Okay. So here we, okay. Okay. And also please note that we involve secondary scorer, yeah, which runs internally, yeah. Prism score, basically. Okay, so just for information, so this is the output of the config endpoint. When the client accesses the config endpoint of respective scoring API, this is the example output. You know. JDP is raising hand.
Oh, yeah. Sugimoto-san, a quick question. So the
Yeah.
scoring API is something that we can externally bring, right?
Mm-hmm.
And we just have to register it with that dynamic scoring CR.
Mm-hmm.
And you're giving an example of the scoring API here, which is driven by LLM.
Yeah, LLM is internally working in the scoring API.
Right.
Exactly here, right? Yep.
Thank you. Now, have you ever considered whether the scoring API should be a standardized MCP interface? Just throwing that question.
No. Yeah, it's an interesting point, and yeah, I think it's yeah. The answer is yes. Yeah, it's an interesting thing to
Thank
see.
you.
Yeah. But for now, the current yeah, it's rather yeah.
No, it doesn't matter. Yeah, but that's
Mhm.
one of the things that can be done, I guess.
Yeah.
Because the idea of configuring and what is the parameters it can take and what is the output it will give sounds like, whatever MCP is trying to do anyway. The dynamic scoring framework is registered as a OCM add-on.
Yes.
Thank you.
Yeah. Okay, so here, so in the bottom of this terminal, you see that we are showing the logs from DSA, and it shows that it is successfully getting score from respective scoring API. So, for example, in the above, you see that these are the output of the /config of respective scoring API, and it shows scoring interval, for example. So in a seconds. So 60, one of the scoring API, LLM Forecast Scholar, it runs in 60 seconds. So here you see that the scoring, the result of LLM Forecast Scholar is actually, yeah, provided in every 60 seconds. You can see in the timestamp. Okay, yeah, just for your information. Okay, so here is a visualization of the scores collected in this example scenario. So there are two graphs here. The upper one is indicates the CPU usage by namespace, and the bottom one is dynamic score, the machine learning prediction. So so we can. In other words, we can say that the above is actually showing the actual utilization of CPU, and the bottom is the prediction. It performs prediction. So so this is so in this example. So the prediction, we think that the prediction helps for example, for the orchestrator to conduct orchestration. Okay, just a moment. Let me finish the video. Okay, yeah, this is just an example, but and in this example, it's quite simple example, but we are giving you a very plain, simple use case, and showing that the framework can be used to make some evaluation across the multiple clusters, and yeah. Okay. I think, yeah, maybe we should spend time on QA. Any comments, questions? Yes, please.
Yeah, thank you. I think I have two questions. The first one, according to the Grafana dashboard. So, do you see the higher score means that that's the less likely to be scheduled cluster? So would you like to explain a bit on what's the schedule implications based on the score here?
I see. So, for example, here it shows that. Well, by the way, the x-axis is time. Okay, so in this example, what it means is that yeah, the orchestrator, from the viewpoint of orchestrator can make a decision to avoid using a given cluster, because it is predicted that according to the prediction, the CPU usage will be increased shortly. So although according to the real-time metrics, although the usage is low here, however, the prediction is saying that the clusters CPU utilization will shortly get increased. So orchestrator may make a decision to avoid you selecting this cluster from the target of workload deployment, for example. That's what that's a kind of implication that we does it make sense?
Yes, yes, thank you. I think so. So, from the orchestrator's point of view, uh, the reason that we are using the matrix is because that accurate to explain like that we using matrix instead of a single value is when we do the schedule, we want to have like not only a single value in a certain time, but a series of datas over a time period to as a way to schedule the workload.
Yeah, possibly yes. Possibly yes.
Okay. So what's a workload that mostly likely to be scheduled in this way? Like, is that a job that will going to be submitted every time or it's like a long running service? So for example, the deployment, so the replica of the deployment will be adjusted by the score.
Yeah, one of the workload that we anticipate that fits well into this AI run architecture is, for example, AI inference workload. As of today in Japan, the demand is not so high. However, we expect that the situation will dramatically change in a few years, and we see that starts happening in US, for example. So yeah, the answer is, for example, AI workloads. So of course, we need to the AI run orchestrator needs to find a target cluster node where there is enough resources. That's one requirements to be met, of course. And also, for example, depending on the data centers, which is distributed in a wide location. So each data center comes with different energy supply. So availability of renewable energy differs, for example, in regions. So that is another important things to consider. So this dynamic scoring can take that into account, for example, by defining a scoring API, which handles the energy-related metrics. Yeah.
Okay. Yeah, I think cost of the AI makes a lot of sense. So if we are talking about the inference service, will that be like the schedule will be like per request? For example, when there is an inference request, we are going to schedule the I don't know, maybe request to a certain cluster, or it's more like skill some workload based on the request. Um, or some like yeah, it's not. Do you have any insight on that?
I see. I think it depends, depending on the service or application, I think. But we expect that usually the model, so the LLM will run, I mean, continuously run once it gets deployed in a certain environment. We expect such kind of use case. Yeah, but depending on the service actually, but so there may be some other types of application that requires deployment and execution in a more instant manner. I mean, its life cycle is shorter than rather shorter. That may also be possible, but yeah, in short, it depends. I think.
Okay, thank you.
Yeah. Thank you. JT, please.
Yeah, so I'm sharing an observation. Let's say I want to deploy a workload which is, I am in the business of deploying workloads which are very network intensive. And I want to appropriately place them in different clusters. So you are probably given me a framework where I can, of course, bring in my own scoring API, but you're giving me a framework by which if I would take the generated score from that the dynamic scoring agent gives from the scoring API, I can actually put it to my placement, and then the placement is up to date. And anytime I try to uh, place the load, that load gets intelligently placed. Does that? I mean, I'm seeing a very generic use case of this, and help me others if I'm telling anything wrong. I'm seeing a very generic use case of this outside telco domain. This is when we are using OCM to manage clusters and manage workloads. One of the things is we must allow for intelligent provisioning, and this gives me the framework to do that. The only thing I must do is bring my own scoring. Does that make sense? And the other thing that I see is that if we could forward the dynamic scoring agent score, the score export is going to Prometheus, fine. But if we could also export that to the add-on placement CR that we have, then it is live. As soon as I create a workload, which is to be, and create a placement, and as long as the placement refers to the add-on placement score, it would be intelligently placed. For example, my scoring API could say that in cluster 1, the network score is very high. That means the network is very busy. Cluster 2, it's very low. So place the load there, etc. Does that make sense?
Yeah, makes sense.
Thank you. Yeah. Yes, that
Yeah.
makes sense. Yeah.
Thank you.
Yeah. August, please. Yes.
Yes. And I think I wanted to follow up with what Joydeep is saying is this is pretty neat, right? Because that, like, what I'm curious as well, what kind of idle resources you could use those nodes for. I mean, they could be anything, right? You're a telco use case here, so they might be for things. But what about when, I mean, if it's an enterprise, they could even just be, I don't know, running backup agents. There could be all kinds of things on there. So the scoring, the little scores that you guys are talking about are kind of fascinating, and it'd be cool for the community to kind of work on different use cases. I'd love to have them join you in Slack and stuff to think about the different use cases of how to score and understanding and learning from you how you're thinking of that scoring agent and plugging it in. So it's more just an observation, not a question. I just really like, I'm already thinking like, yeah, when that idle resource is becoming available, think of all the neat things you could do with it that that aren't being wasted, that you could even tap into the GPUs on it, or it's so cool. So that's just more of an observation as I've been reading and learning. And I'll leave a little note. There is a document covering all the information, like a write-up on it, but I put that in there. But yeah, I just really wanted to call that out because I keep, I hear this telco use case, but it's just so big where this could go. So thank you guys. I think that's really excellent.
Thank you. Thank you for your comments, West.
It
Yeah.
gets the mind going.
And I forgot to mention that there, we shared a Google Doc with you. So
Yes.
please take a look, and you'll find some information here. And as August mentioned, from SoftBank point of view, we are the reason why we are promoting AI Run is that we would like to make the best utilization of the computing resources. Because as you know, the conventional run computing system is dedicated for a specific purpose. I mean, there's no chance to execute any computation work for other purpose than run. So from a viewpoint of investments that we made towards the infrastructure, the return is quite limited. Yeah, of course, the return. I mean, the main purpose is, of course, to run the system in a stable manner. However, there should be a chance that if there is any idle computing resources, we would like to leverage them. And I mean, in the era of virtualization, I mean, virtualization technology is available now. So why not? So that's the background.
I love that. So why not? Yes.
Yeah.
That's awesome. Very cool.
Yes, please.
Yeah, sorry, I have another question. So I think, so as you know that we have the placement score in the OCM API, and from my understanding currently, the main differences here is when we use placement score in the placement, we only use the score with the current state, but if the score is in the matrix, the scheduler basically can understand the trending of the score, like a time series data, like whether the score is increasing or the score is go down. That's something that we cannot get from the placement score itself. I wonder whether that's one of the reason, or whether that is a very helpful information for the scheduling. That's an interesting thing. Maybe we need to discuss later. Another interesting thing is, as you know, that placement today is only going to select clusters, like based on the current state of the clusters, we select which clusters is good for the current state. So it's not quite tied to the workload. It's only to do the cluster selection. So, well, I mean, is that something that we will try to handle is more into the workload, or the score is still focused on the clusters? That's that's something that we also can discuss in the future. I know that Tyler, who is in another company and is a maintainer of the OCM, is interested in the scheduling part, and they think there's some gap on the score, add-on placement score today. So we can share the doc with him also to check whether it also like to fill some gap for the. Yeah, but this is very great work. Thank you very much.
Thank you very much for your comments. I understand, and I think we need more a discussion, and we need to think more about how we can relate this to the placement and so on. And yeah, thank you. JD, please.
Yeah, and I'm responding to George, and he has totally agreed. And I'm not quite sure what gaps in the add-on placement score is, but that would be wonderful to have a discussion on. And the other thing I was thinking, I mean, obviously scoring API is ours, whatever we bring, right? And looking at the Grafana graphs, I was thinking perhaps a scoring API score could be if you want to place something on this cluster to run in the next 1 hour, the score is 5. If you want to run something on the cluster for next 10 hours, the score is 15. There could be different ways of scoring. Here, for example, it's obvious that you wouldn't place anything. The periodicity of the data this is all mocked up, fine, but this data goes high very quickly. So you would not place anything on this cluster, right? If you want to run a load for a very short term, if you want to run the load only for less than 5 minutes, then you can place it. If you want to run it for a longer, then probably you will find, so we have lots of ways by which we can do the scoring intelligently, which an ordinary placement would not be able to do, right? This is totally in our control.
I agree. Yeah, you're right. Yes.
But
Yeah.
this is very good. This is very good. Thank you. This is very inspiring and sounds like we can use it generally.
Thank you. So yeah, we appreciate your feedback. Yeah, whatever kind of feedback and comments are very helpful for us. So yeah, thank you. Okay.
Yeah, I think we're wrapping up the questions here. We're towards the end of time as well. Gentlemen, this was wonderful, and it's great to see the engagement and everything. It's really appreciate you taking the time to put this together. As I said in the chat, there's a document there. The team is in OCM Slack as well, so reach out to them. Everybody's busy, but reach out to them. And this is super cool. So thank you so much for taking the time to share with the community and welcome into the OCM community. It's really good having you here. Mike, if you wanted to sort of sign us off with the official Mike sign off, that would be terrific. So thank you so much.
Yeah, I'm just echoing everything August said. Ditto, and thank you all for joining today. Take care, everyone. Bye.
Thank you.
Thanks all. Thank you.
You.
Bye-bye.